All right. Hello, everyone. Thank you for coming to my session about rescuing GitLab from CSS Bloat. This is my first time doing this format, so it's kind of different, but we'll see how it goes. So if you want to follow along, I have a link for the slides, bit.ly/CSS Bloat BR. I've also tweeted it out in case you're following the conference handle as well. So a little bit about me before we get started. My name is Clement Ho. I'm the front-end engineering manager at GitLab. Who here has heard of GitLab? Raise your hand. Awesome, awesome. Who uses GitLab? Oh, okay. Not as many, but we'll get there. I live in Austin, Texas. I'm not native to Brazil. This is my second time in Brazil. And if you want to come check out Austin, this is kind of what it looks like on a good day. And if you want to follow me on Twitter, Clem Makes Apps is my handle. So if you have any questions about what I'm talking about, comments, I'd love to hear about it on Twitter. So for the rest of you guys that have not heard of GitLab, GitLab is a single application for the entire DevOps lifecycle. So what that means is that we try to make writing software faster. And in addition, we are hiring. So if you recently heard online, we recently raised $100 million, and now we're valued at $1.1 billion, which is really cool. It makes us a cool unicorn. Unfortunately, we're not hiring in Brazil yet, and hopefully that will change. That is actually a link to an issue of us talking about how we can open that up to Brazil. The reason that we haven't been able to hire in Brazil recently is just more of the different laws and the different requirements that are needed to hire in Brazil, so we're trying to work on that and make it more accessible. So to start off, what is CSS Bloat? Let's define CSS Bloat. CSS Bloat, the way I would look at it, is CSS that's out of control, it's difficult to maintain, it's starting to impact performance. A lot of times it's kind of like the sinking ship that we see in this GIF. You don't really know that you have CSS Bloat until it's too late, until you're underwater. So how did we get CSS Bloat? How did GitLab get CSS Bloat? But in order to do that, we have to examine our history. We have to understand how the boat was before it started to sink. So GitLab, if you guys know about GitLab, the history, we used to have this really ugly logo. This fox kind of gives you nightmares. We have this idea of iteration at GitLab. So the idea that we kind of want to build one thing at a time and have minimum viable change. We don't want to build a car from a wheel, but we want to go from a skateboard to a car. With this kind of iteration flow, we kind of have to build things incrementally in a way that it's sometimes hard to determine what you need for the car. For example, the wheel in the skateboard doesn't necessarily you don't use the same wheel in a skateboard as you do for a car. So with that, there's a lot of debt that acquires over time, but we're also trying to have a good product fit with the market. And so that's kind of how the trade-offs with that approach. So GitLab originally was your classic Ruby on Rails app. We have DOM manipulation using jQuery, HTML templating using Haml. We have our backend written on Ruby on Rails, and this is our classic app that we had. Over the last few years, we've also made a lot of front-end improvements. So we removed turbolinks. If you're not familiar with turbolinks, it's a Rails gem that basically dynamically injects and evaluates JavaScript on each page so that certain stuff on your page that doesn't change over time. So for example, the nav bar will be able to stay consistent. You don't have to refresh and re-get that from the server. But with that, there's a lot of trade-offs having turbolinks. Even though it technically improves the speed of your website, it actually makes it harder to track event listeners. You have to add it and remove them as your page changes. So it adds a lot of extra bloat. So we removed that. And we also converted CoffeeScript to ES6. A lot of features in ES6 was what CoffeeScript offered for us. And ES6 also has a better adoption than CoffeeScript, so we changed that. We started using NPM for tracking our dependencies on the front end. Previously, it was all in gem files in the Ruby stack. And so we started to see more separation between the backend and the front end. We started using Webpack. That kind of helped us use the Webpack development tool so that we can start doing hot module reloading, a lot of cool things that Webpack offered. And we started using Vue.js for our pages that had more high interactive DOM elements. So previously, if we used jQuery, it would be a pain in the butt to scale it and also keep the code maintainable. But with Vue, it does a lot of the rendering for us, so we don't have to worry about that as much. So you might be asking, what about the CSS? That was a lot of cool improvements with front end, but CSS wasn't even mentioned on that list. So this is our CSS. CSS was kind of a drag. If you look at this chart, the CSS file size over time just increased linearly, although not each version is the same time period. So version 8.x was probably a lot longer than 10.x, but you can kind of see that there's a general trend towards increasing. So this is bad for CSS performance because that means users that are trying to use GitLab will have to eventually download more and more CSS to their browsers, to their phones. This is going to increase the page load time, which is not most ideal. In addition, our lines of CSS code has also increased over time. So this is 11.0 came out like a couple months ago. Well, maybe like 4 or 5 months ago. So it's sometime this year. But you can still see it's kind of growing linearly. And that's not a good thing because as you have an established product like GitLab, a lot of the UI is actually defined. Even as you add more pages, you rarely have to add new UI elements that you haven't seen before. So what this means is that as we're adding new pages, we're adding more CSS selectors to style each page, and that's just adding more code complexity. When you add more lines of code for CSS, there's a cascading effect with cascading style sheets, which makes it harder to maintain. And let's say if you want to override something, you're going to have to write deeper level selectors, or you have to use the important attribute. All these aren't really good strategies for keeping your CSS reusable. So one of the cool things about GitLab is that our code is open. Even though our Enterprise Edition is proprietary code, it's open. This specific link is to our Community Edition that's completely open source, MIT license. And with that, we can kind of show you some of our debt. It's not something that we're proud of in the front-end team, but it's something that's real, and this is what we're going through, and perhaps you can relate, and perhaps this is something you can learn from. So here we have an example of our Notes CSS. It's a small chunk of what we have. And if you want to really check it out, there's the link below. And here is an example of 5-level deep selectors. So 5-level deep selectors for the paragraph tag. If you wanted to change the paragraph display, for example, you want to do display block for the paragraph tag, you're going to have to either use a deeper level selector to override it or use the important attribute. So this is not great. Page-specific CSS is something that we also had. So in GitLab, we have the framework, so more like CSS for each component, like button.css, but we also started listing off a pages folder with CSS for each of the different pages. This is not reusable because let's say you added a new UI element to, let's say, the admin page, and you eventually want to add that element to a different page. It's very hard to cross-reference what you're using in admin.css and make it reusable. Well, what end up happening is that you'll just rewrite your CSS, different ways to implement the same thing, which isn't great for user interacting with your product and also for the maintainability. So here's an example for the inconsistencies. So here you can see, this is actually a screenshot from GitLab this week. And as you can see, the caret position is actually closer for the SSH text, but for the other icon, it has more gap. So this is a slight inconsistency. It doesn't ruin your GitLab experience, but this is just one of the small side effects that you can start seeing as our CSS has increased over time, the effects that it has. So overall, contributing factors to CSS bloat, a lot of it comes from not prioritizing to fix the debt early on while the boat is still a boat before it's sinking. And at the same time, it's also difficult to maintain without a set paradigm. And with that, I also wanted to share a few quick tips that GitLab has done to do some improvements that take a little bit of effort compared to, so a lot of improvements for a little bit of effort. That's what I'm trying to say. So one way, if you haven't done it, is to gzip your CSS and to add a CDN. That will decrease the time it takes to load your CSS on the browser. It's a very small win, a big win for a small amount of effort. And the other thing is to always minify your production CSS. So that's two key ways that take a little bit of effort, but the gains are a lot bigger compared to other things that you can do to improve your CSS. So I would say that the biggest cost of CSS debt is maintainability. So if you've been keeping up with CSS trends this year, you might have heard LinkedIn created CSS blocks. They announced that earlier this year, talking about that's their approach to handling CSS. One of the quotes that they had there was from this guy. I'm not going to say his name right, but Hans Oliver Mayart. He said, selective performance is not something to optimize for. Selective performance is irrelevant, and the price we pay for optimizing for selective performance is indeed terrible. We micromanage our work for gains that aren't even noticeable. So with CSS, it's such a big domain. It's very easy to hone in on trying to improve it in the wrong ways. So it's really important to try to figure out which part to focus on in CSS to make it maintainable. And a lot of times the selective performance isn't one of those. So the main thing, I think, that in terms of getting out of CSS bloat is to try to figure out a consistent strategy for organizing your CSS. If you have a good structure to your boat, you'll be able to go further and not sink. So what are some strategies? One of the most common strategies is object-oriented CSS. And this is the concept of separating your structure and containers from your skin and content. So you kind of look at your CSS and you kind of divide it into two groups. The structure talks about more of the invisible features. So for example, the margins, the padding, while the visible features talks more about the color and the font, things that you can see. So if we were to go through our previous example of what we have on GitLab, and let's say we're going to use object-oriented CSS to organize our CSS, this is kind of an example of what it would look like. We would have our note structure, all these kind of doing the display, the behind the scenes kind of thing, and then we have the skin that kind of styles it as the theme, so to speak. So object-oriented CSS has different trade-offs. One of the advantages is that it's a very defined boundary on which style should belong to which class. It's very clear what is something you see and what's behind the scenes. It also follows a similar paradigm as object-oriented programming, which a lot of us computer science background, this is kind of a good thing because it's something we're more familiar with. The disadvantage is that you are increasing the number of classes added to elements. So, for example, in the past, maybe you just added a notes class to your element. Now you have to do a notes structure one and a notes skin one. So you're technically adding more to your DOM, but there is that is kind of part of the organization. Another disadvantage is that it also couples the content with presentation. So some component libraries are trying to go that direction, so it could be an advantage. But for some people, that coupling isn't what they're looking for. So if you want to learn more about this paradigm, here's a link as well. So another popular way of organizing CSS is called SMACS, which stands for Scalable and Modular Architecture for CSS. So previously in object-oriented CSS, we broke it down to two groups. With SMACS, we're actually breaking it up to 5 groups. We have the base, layout, module, state, and theme. And each of these are trying to help create more separation in your CSS. The base kind of creates your default values. Your layout is similar to the structure in object-oriented CSS, where you have your containers. Your module is about separating concerns, and your state is about your look across state. For example, like let's say you have a button as a focus state, that would be the state. And then the theme would be setting up the skin similar to object-oriented CSS. So once again, if we kind of go through our previous example and we convert it to SMACS, this is an example of what it would look like. Our base would be kind of setting the margins back to 0, similar to normalizing it. Our module will be setting more of the specific styles for that class, note, entry, message. And then the theme was more of the visible features. So SMACS trade-offs is that it's one of the easier to understand compared to other paradigms, easier to demonstrate because there's 5 clear buckets. In object-oriented CSS, you're still having these 2 big categories that can be very hard to figure out how to organize within those 2 categories. In SMACS, you have 5 categories, so it's a little bit easier to define them. And it's also known to scale across small and big projects. So a lot of companies have used this in the past, so it's proven to stand the test of time. Disadvantages is that compared to the other popular paradigms, this is one of the less adopted ones. And it can also be sometimes difficult to kind of determine which category, depending on the module and other categories, because module seems more fuzzy, it's not as clear. And so with this, I would also say that if you're trying to use SMACs, you would want to just be consistent with your approach rather than trying to always figure out whether it should be in one category or another. And if you want to learn more about SMACs, there's smacks.com. So another popular paradigm is BEM, which stands for Block Element Modifier. So it's the concept of trying to break up all your UI into blocks. And the blocks would actually stand for reusable components. The elements would be kind of the components inside the block that are very coupled together, so they're always grouped together. And the modifier would be kind of changing the state, the appearance, what it looks like. So if we were to go through the example and convert it to BEM, this is potentially what it would look like. We have the notes, which is the block, and the message is the block. The element is the header, and the link, and description, and then the modifier would be the theme default. What's really interesting to note about BEM is that they're really big on underscores and dashes, and so you kind of see some of these in this example. So BEM is great because the modular blocks reduces a bunch of conflicts. You're kind of taking away part of the cascading style sheets into BEM. So there's decreased selector specificity because you're starting to group everything to block element. So there's not ever a chance of 5-level nested deep. And it's known to scale across the different sizes of projects. The disadvantages is that you can start seeing how the class names can get really long. And also, as I mentioned earlier, of course, depending on the certain situation. And so that could be a learning curve because most of us don't really mix those or use those in our CSS class names. So that's something to be mindful of. And if you want to learn more about it, getbem.com is a great resource for that. So another up-and-coming paradigm to organize your CSS, I would categorize as CSS and JS. So the reason I say categorize is because there's multiple ways to implement CSS and JS. Styled components is one implementation of it. View, we have view files where you can actually have the style tags inside the view file to kind of bundle it together. But I'm going to abstract it away in this part of the talk to explain, we're just generalizing the concept of having CSS and JavaScript together in one component. So with this approach, there are some really interesting advantages that you don't see in other approaches. It's easier to find dead code because your CSS is very coupled to your JS, which is coupled to your HTML. So you can start seeing easier when you're not using CSS, you can remove it. In traditional other methods, it's a little bit harder to find that unless you run through other tools, but it may not be very accurate. There's also interesting parts with tree shaking with CSS. So if you're not familiar with tree shaking, it's the idea where we don't load the assets that are not needed for the page for the user. So we're starting to decrease the number of things that are loaded to the browser because you don't need to load CSS for your login page if you're on the home page. And so if you start bundling CSS into your JS, you can start seeing the parts where we don't load the JS, we can actually not load the CSS at all. So you can actually decrease the amount that you're loading onto the browser for each page. The other advantages is also you start seeing less overriding of styles. You're also, similar to BEM, starting to decrease the cascading effect of CSS by using CSS and JS. The disadvantages is that it's still very new. It's only been around for a couple of years. It's still not sure how the scalability challenges are. So that is something to take into consideration when implementing this way of organizing your CSS. And the idea of decreasing cascading styles can also potentially lead to code duplication depending on how you've set it up. So that's something to be mindful of. And cssandjs.org is also a great resource for this. So you might be asking, Bootstrap recently did a redesign, rework, rewrite for their whole code base for version 4. So what did they do? What paradigm did they do to try to keep their CSS consistent? So one of the cool things about Bootstrap being open source is that we can just kind of take a look at GitHub. So they seem to separate based on components. If you can kind of look at here, we have the alert.css, badge, breadcrumb, and so forth. So this is really interesting compared to the other paradigms we've looked at. And then if we look even deeper, we have this button.css with its own styles, and you kind of see some of the different states being separated out. But for the most part, it kind of follows its own convention compared to the other popular ones we've talked about. So with that, you might ask, what about GitLab? What did we decide to do, knowing all this information about writing scalable CSS and writing these different paradigms? So a side tangent is that with GitLab, we're also trying to implement our design system. So a design system, if you're not familiar with it, is kind of a way to write design guidelines that UX usually drives and says, hey, this is how we want things to look. They start building kind of like a brand of what you want. For us, the UX team has started to develop this over time, and our current UI doesn't really implement some of these design systems. So we actually want to start implementing our design system to fix these UI inconsistencies like the one I showed you earlier. So with that, that's kind of how our approach is factored by this decision or this understanding. If we didn't have the design system going forward, I've chosen a different way to go forward. So with that, GitLab, we've decided to build CSS Lab. So what is CSS Lab? It's a CSS framework that's built on top of Bootstrap so that we can have another layer of CSS that specifically styles our GitLab components to make it look like GitLab style. And that's the project link if you want to learn more about it. And we've decided to use a similar CSS organization paradigm as Bootstrap. So since we're building on top of Bootstrap, we don't want to rewrite things for the sake of rewriting. We don't want to reinvent the wheel. We've decided to use a similar paradigm so that we can kind of contribute up if we find things that Bootstrap needs to be fixed. And it also helps us stay consistent across our code base. So the idea with our CSS and trying to get out CSS Bloat, the idea would be to write these new CSS for each component, document them, and then replace them on GitLab and kind of iterate through this cycle. We're really big on iteration. What's interesting is GitLab, we're really big on continuously shipping. So every month we actually release, and actually today is the 22nd, so we actually released a new version of GitLab today. And so with that, that kind of adds different challenges to all this, this method that we're trying to go. Different challenges include being a lot of components in GitLab because GitLab is pretty big. And we also have 500 routes on GitLab, over 500 routes. So if you think about replacing each component on each page, this kind of adds up a lot. So this is kind of different challenges we have to face with trying to replace all these CSS. But with that in mind, the goal that we have is that after CSS Lab is written, we would write these custom view components that implement these styles, and also have Ruby HAML helpers for these components. The idea is to abstract away the styling for our developers, so the community who wants to contribute, our backend engineers or front engineers, can easily add these components and not have to worry about styling ever again. Because CSS is hard, and if you don't have a good understanding, it's easy to mess it up. So the goal was to make happy developers. Unfortunately, we also still want to have front-end features delivered each month, even in light of all these components that we're trying to replace. And if we look at the front-end team breakdown at GitLab, only a small percentage is actually working on these components, and the rest are more focused on building features. So that's kind of challenging because that creates kind of this effect, where you feel like a lot of your team is trying to build these new features, and we're trying to be behind them trying to replace all these components. There's just a lot of work, and it's kind of an uphill battle. So we tried to think about it a little more, and we kind of learned that a lot of the new features that were written are in Vue versus not Vue. So how can we use that to our advantage? Is we started to think about what if we created Vue components first. So previously we talked about creating our CSS framework first and writing the Vue components next. What if we switch that around? So the concept was, what if we migrated our existing, what if we added Bootstrap Vue to our code base so that as these new features are written, they can implement Bootstrap Vue, and then we can start replacing them after we finish the CSS Lab. So this way, we end up having one single place to replace the styles versus having all these new features that we have to replace. So this is more of the flow that we're trying to move forward with. The idea is to wrap Bootstrap Vue. Bootstrap Vue is the Bootstrap implementation in Vue, so it's more familiar with Vue code, so it's easier to import into existing Vue files. And with that, we want to wrap each of these components so that we can add our specific styles that we already have. And then that way our team can implement them. And then when it's time to replace these styles, we just replace it in one file. And so this would be more efficient. We only replace them one time with these new features versus replacing all these new features that are written during this time of writing CSS Lab. So you might be asking, where are we today in this process? This all sounds like happy things, but this also sounds like a very long process. So we are here today in this step. We are wrapping the components and we're delivering it to the team to utilize to speed up their development and also to prepare us for our next phase. And we named this Vue component library GitLab UI. GitLab UI started about 3 months from today, and we decided to use Storybook. Storybook is an open source project to help you visualize a lot of your components. You can interact with them on the browser. It's a really great way for developers to figure out what components you have in your component library and also read documentation about it. So it's a really great resource if you're interested. It also works for React and a few other frameworks, so highly recommend it. But we decided to go forward with Storybook. We also added this thing called Review Apps. Review Apps is something native to GitLab, but it's the idea where every time you create a merge request, it will deploy an environment so you can test it out. So we implemented this so that it's easier for reviewers to review code. Whenever someone adds a new component, we can easily check out the URL of where it would deploy to for the documentation for the Storybook so that we can make sure it's rendering correctly and so forth. Another cool benefit of Storybook is image snapshot. So something that we didn't even really consider when we were trying to refactor our CSS, trying to get us out of the CSS debt, is image snapshotting. So in the past, our companies talked about, hey, why don't we add visual diffs? Make sure we're not adding visual regressions whenever we change CSS. But that's a hard problem to solve because if you do visual regression testing on each page, if you change like the font size of one, it's going to just give you a lot of false positives. So that's not great. But with Storybook, we're able to kind of start doing image snapshots on the component level. And component level, that's really beneficial because they rarely change with false positives. So here's an example of the image snapshot of an output if the image snapshot fails. So on the left side, you have what it's supposed to be based on the code, based on previous examples of the image snapshot. You have the right where it's the size, where the test is generating it, and then the diff is in the middle. So in this example, we actually just increase the spinner by 5, and it creates an error. It fails to build. So this is really nice to help us be more proactive as we go through this process, that we don't break any CSS, break any CSS to impact our users. Another cool thing is that we added Storybook Knob. So this is a really cool Storybook add-on that takes like a few lines of code, but basically it lets you start manipulating the props of your UI components. So in this GIF, I'm changing the props on the progress bar to change the value and the variant. This is really cool for the rest of the development team because now they can start visualizing how this component works. They can look at the code and start really figuring out how to implement it in a way that they couldn't do it before. Although progress bar is just a simple example, most of us can probably visualize 30 to 50%. This can start being really helpful when we start building more complex components that are harder to visualize. And let's say more complex components that are made up of smaller components, let's say like the nav bar. Another thing we added was Readme. This is also similar to the previous page. Adding a Readme to Storybook is really helpful because we can start having documentation. Previously, you have to look at the view file to kind of figure out what it's going to do. And we also made sure it was in Markdown using one of the add-ons as well so that we can start writing it in one place and having it imported to multiple projects. So we have our design system website that we want to have these components and their documentation, but we also want it in Storybook. Having it in Markdown leverages Markdown so that we can have it on multiple pages and have it one single source of truth. We also added this cool tool to auto-publish to NPM. So if you're not familiar with semantic release, it's a really cool library that helps you automatically publish whenever you run their command. So we added this as a CI job, and we're actually automating it so that whenever, what it does is it parses your commit messages, and if it sees a specific commit message that follows their specific convention, which by default is the Angular convention, it will automatically prepare the release, whether it's major, minor, or patch. It will automatically determine that and publish it. So this is very helpful for us because this is specific. This is normally like a more tedious process. So with this endeavor, it's challenging. As I mentioned earlier, 500 routes. This whole process takes. Is that over time, the last mile is the hardest mile, and it's also not as critical. It may not seem as critical compared to delivering new features from a product standpoint. A lot of these things are more long-term gain versus short-term gain. So there's a lot of pressure from different teams whether it's going to be successful or not. But in light of that, we still have very ambitious, audacious goals that we want to achieve through this process. We want to use it, create this system so that we can accelerate development for the team, abstract away the idea of styling away from the team, have styles that are very consistent, and we can also start creating more UI consistency with GitLab so that we create a better user experience. So the goal would be kind of in the future to have a chart like this where as we continue doing this work, the CSS lines of code would kind of plateau because as we add new pages, we should be able to use existing UI components and their styles versus writing new styling for every new page. So a few main takeaways I want to leave behind for you guys. I want to make sure that you guys know that if you're trying to get out of CSS bloat or CSS debt, you don't always have to pick one paradigm to be consistent to kind of get out of that. You can mix and match. You kind of see how Bootstrap kind of creates their own flavor. But the most important part with that is that you want to be consistent. You want to document how you're doing it so the rest of the team can learn that. Once you're inconsistent with how you're organizing your CSS, that's when the chaos starts. And if you're interested in what we're doing and if you want to contribute to our discussion or track our effort, you can check out our project at the link below. And what's cool about this is that it's completely open source. So if you want to learn about how we're using Storybook, some of the configurations that we've done, you can just check out this project and leverage what we've done. No need to kind of research everything on your own. And I wanted to leave you also with some resources. There's a few good resources here about writing maintainable CSS, different tools to kind of analyze your CSS. Keep in mind, there's a lot of information you can get from your CSS stats that may not be as useful. So you kind of have to learn how to discern the data and figure out what's most important to focus on. And with that, I want to thank you for listening to my talk. And we also have some GitLab swag. So if you want some GitLab swag, come find me. We also have women's shirts because we're really big on diversity. So feel free to come talk to me afterwards and love to give it to you guys. Thank you.